Hello everyone and welcome back to our channel Biodiversity and Conservation, and I'm Subhalakshmi Rao from Ambika Prasad Research Foundation, India. And today also we are going continuing our topic about characteristics of solid waste. Previously we have talked about the physical characteristics of solid waste, and today we are going to complete the chemical characteristics of solid waste, and this is third part of unit 7 of UGC net environmental science subject. So let's start. So today we are going to discuss about the chemical characteristics of solid waste. It is very important to know about the chemical characteristics of the solid waste so that we can um, create the different processing and recovery methods of solid waste. And we know that waste is a combination of combustible and non-combustible components. So some waste products can be burned out and some cannot. So that we can know from taking into consideration the chemical characteristics of waste. So after knowing the lipid, carbohydrate, protein, natural fibers, or synthetic organic material composition of any waste material, we can know that whether we can burn it or whether we have to implement different disposal methods for the waste materials. There are also some other properties like heating value, ultimate analysis, and proximate analysis, or the freezing point of ash. So all those things are taken into consideration to develop any strategies for these solid waste management. Now, lipids. As we all know, lipids are mainly fats, oils, and grease. So the principal source of lipids in garbage are from cooking oil and cooking fats, like from animal fats which we throw out, and from cooking oil that we normally use. So those are the waste material inside in the garbage. So lipids actually have high heating values. That means it has high melting point. So it makes the waste with lipid content, high lipid content, very suitable for energy recovery. Means we can uh, burn those things and uh, generate energy from there. So those type of waste can be used the, for extracting energy, whether it may be form of heat or any other thing that is decided upon by the solid waste management programs. So since we know that the lipids are of high melting point and becomes liquid if it's heated for a long amount of time, then the they actually add liquid content to the waste, which increases the tension of disposal methods. So but it is a plus point here that they are biodegradable and they have low solubility in water, so their degradation is very slow and it remains in the environment for a long amount of time and creating so much other problems. Now we have carbohydrates, which is generated from the food sources which are rich in starch and cellulose, and they are easily biodegradable and convert into carbon dioxide, water, and methane. So during the decomposition process of carbohydrates, it gets so much flies and rats and other animals, and so it's to be decomposed quickly so that those animals don't create so much diseases in that environment. So for that we have to decompose these carbohydrates quickly. Now we have proteins, which contain carbon, hydrogen, nitrogen, oxygen, and organic acids with amino groups. So they are found in food and garden waste, and their decomposition actually produces amines, which create very unpleasant odor. So their decomposition has to uh, taken into consideration because it takes a large amount of time to decompose also. So separate management techniques to be developed for the decomposition of proteins. Now we have natural fibers, and they are the natural products that contain cellulose and lignins, and they are non-biodegradable mainly, and these are found in paper products, food, and yard waste. And due to the high amount of cellulose, they have to be incinerated or burnt to get them to degrade quickly. Now we have synthetic organic materials like plastics. So plastics have become a headache in the recent times, and they do not degrade easily, and their presence in the environment creates a lot of problems. So we have to develop different disposable method for this, because the plastics have a very high heating value, and from plastic heating we can get energy, and that can be used for different purposes. But uh, nowadays the plastics have polyvinyl chloride, because and when we burn these PVCs, we get acid gas and dioxin gas, which is very harmful and carcinogenic for organisms. So we have to take into consideration this, because it's really harmful. Non-combustibles like glass, ceramics, metals, those are non-combustible. So we have to imply a different strategy for the waste management for these substances. Now, heating value is a very important characteristic that is used for solid waste management. So the heating value is mainly calculated using bomb calorimeter test, in which heat is generated at a constant temperature of 25 degrees Celsius, and from the combustion of a dry sample the measurement is done. And since the test temperature is below the boiling point of water, that is 100 degrees Celsius, the combustion water remains in liquid state. So when the combustion temperature uh, reaches 100 degrees Celsius, we get vapors, and those vapors, if they are normal water vapors, then it mixes with the clouds and gets back into the environment through rain and all those things. But if those gases may have dangerous or toxic gases, then it's very um, dangerous for human health. So heating value has to be taken into consideration while designing any device or technique for solid waste management. Now we have ultimate analysis. It mainly refers to the analysis of waste to determine the amount of carbon, hydrogen, oxygen, nitrogen, and sulfur present in it. And it is very important to determine these composition because from that only we can know the organic matter that are present in the solid waste, and from that we can find out the C by N ratios, and we can know that if carbon is present more, carbon and nitrogen, their ratios actually say that if that solid waste can be used for biological conversion or not. So high carbon compounds can be used for biological conversion, means that they can be degraded biologically. But if they have sulfur or those things, then they cannot be given back to the environment like that through biological conversion. They have to be degraded using different methods. Now we have proximate analysis. In proximate analysis of waste, it determines the moisture or volatile matter or ash present in that waste material, and from get knowing the moisture content, we can know that the moisture adds weight to the waste, which um, sometimes increases the heating value and sometimes doesn't. But the evaporation of water which happens, it reduces the heat released from the fuel. So uh, if any waste material has more moisture, then we cannot use that for getting energy. And next one, if we know the amount of ash present in the solid waste, then we can know that the ash adds weight without generating any heat during combustion. And from the proximate analysis, we can also know that whether any solid waste has volatile matter or not. So if it has volatile matter, then from heating it will convert directly into gases, and if those gases are poisonous or not, then that will decide uh, the incineration process is good for this matter or not. Then if we know that there is fixed carbon in the solid waste from proximate analysis, then we can know that how much longer the waste will take to burn out or for the complete combustion, and how much is the retention time taken, means how much time it will take to burn. So from the fixed carbon we can know that. Now we have fusing point of ash. The fusing point of ash is actually the temperature at which ash is formed from burning any waste, and generally for formation of a solid uh, by fusion from the solid waste is 1000 1100 to 1200 degrees Celsius. So it's a very high temperature. So this is all from me today. Thank you for listening to me.